The Termination Station, done by us, Nathan, Braden, Jackson, and Carol. All right, our prototype refresher. Our idea is a nerve auto turret. It's a turret that just face tracks, finds a face, and then automatically or remotely shoots at the detected face. Our objective out of this project is to learn how to use facial recognition software, learn and design our prototype of our idea, and then learn how to use different Arduino components that we've learned over the semester, as well as managing expectations and having backup plans.
Okay, so our first two parts are the motor shield and the stepper motor. So the motor shield is kind of it just attaches right onto the Arduino board, and we have two stepper motors, and they'll both connect to the motor shield, and that makes it so that they can both run. And then for the next two components, the relay and the step up, the relay allows current to flow through the gun. So our gun, it's a battery powered gun, so it has to like whir up before it can shoot. So the relay allows that to happen. And then the step up is externally charged, so it can plug into like a computer, an outlet or something. And then you can adjust the voltage being sent to the different motors. So for the step up motor, we have two of them, and they're both adjusted to 12 volts each. And then the servo would be 8 volts. And then the Nerf gun is obviously like the main portion of our turret. It's what actually shoots. And then the servo motor is what will be pulling the trigger. So we'll have it mounted on the side, and when needed, it'll pull the trigger for us.
All right, this is our design again. So we got the gun, and then the camera will be set up right on top. The rod will be moving the gun up and down, and then there is the main turning plate on the bottom that will be moving right and left. For our project's achievements so far, we have the facial tracking working properly with Arduino, and then we have the 3D printed flings and drive shaft for the rotation of the base, as well as the rotation of the Nerf gun. We also have the base plate as well as the supports all cut out, and then we have the stepper motors working great for rotating as the base of the base and the gun up and down.
So our current and potential problems that we have been experiencing and we could possibly experience. So right now, our biggest problem is the servo pulling the trigger. It's just inconsistent, and sometimes it's been like too weak. It hasn't pulled the trigger all the way. So we're hoping that we can go back, debug, and figure that out pretty soon here. And then our potential problems are mainly mounting the gun and the servos on the supports. We haven't had everything in the same place all at once, so we're not exactly sure how it's gonna go, but we have a decent idea, and I'm sure Braeden might talk about that later on. And then turning the gun with the steppers, so moving it up and down. Like I said, we haven't had all the components together, and the stepper is gonna have to be attached to the support. So for us to really figure it out, we have to have everything together. And the gun may be too heavy, so we might have to remove parts of the gun. So that's just possible problems for later on. And then so problems that we did experience that we've solved. So researching like how we've solved them, we've researched causes of our problems and what could be done to fix it. For example, we asked AI for help on our facial tracking code because I mean it's it's hard code. So AI really helped us on that. And then we've had issues with the face tracking output. So we've had issues with like how the software for the facial tracking will communicate with Arduino, but luckily with some debugging and then like figuring out different format for the code, we figured out the speed, which is below the speed for the output, and also how they can both communicate together at once.
So far, our learning experiences have been, we learned how to use Tinkercad. how to use different libraries in Arduino and Python to get the code to work properly. We learned how to 3D print pieces, and then how to debug our code and mess around with the hardware to solve our problems.
Hello, today I'm going to be talking about the supports that we made for our Termination Station Nerf gun turret auto facial recognition gun. These are the pieces that we cut out. This is actually the base for it. I use this material plastic to cut it out with. Now to get these diameters on these parts, I used the CAD software and ran it through a water jet machine. A water jet machine is a large machine about the size of a bedroom that cuts a tiny, or sends out a tiny stream of water that's very powerful, and it cuts through anything from plastic to stainless steel to carbon fiber. And the way this is set up is the base is obviously the bottom, and we have a flange here that the motor will go into, and then this will sit on top of the base like that, and this is where it spins. The motor goes right here, and then we have the two supports that will hold the gun in the center up here. To do that, to hold the gun in the center up there, we're going to be using this other shaft that we used, and this is going to go like so in here so that it can spin freely and allow the gun to move with the motors that we have it programmed to do so. We used a 3D printing software to make these pieces, and that's about it for the supports. So.
Hello, my name is Braeden, and I've been working on a lot of the circuits that have been involved with this project. The first thing I did was created a Python script using OpenCV to detect faces through a webcam. Using the Arduino's built-in serial ports, I have the Python script sending X and Y coordinates of the detected face, and then this information is actually received by the Arduino, which maps the information from the size of the screen to the angles of the servo. And this provides a very smooth tracking implementation for the motors. Originally, I was only able to run the script at around 1 frame per second, but by optimizing code and fixing errors within the serial port information, I was able to get the output to be very fast. After this, I got to work on the motors. For our servo, I was originally attempting to power it with 5 AA batteries in series to create the 7.5 volts needed to run the motor, and this did not work. The motor was stuttering really badly. I put this to the side and I began to work on the motor shield, and I found out how to mount the motor shield after watching some videos on YouTube. And at first, the motor shield wasn't being detected by the Arduino, and we thought it might have been broken. But we decided to solder the pins of the motor shield down to see if it would make any difference, and it did make a difference. Our board was connected, and after that, it was very easy to get the motors to work. They just needed to be plugged in. And one thing that took too long to figure out was the step-up converter. But once we realized that it was just a micro USB port that plugged into it, we were able to adjust the voltage to be 12 volts, which is what we needed, and we plugged that into our motor shield. And we also realized afterwards that we could use this to power the other servo motor that we were using batteries for before by adjusting it to 7.5 volts, because we got 5 of those with our Amazon order. And for some reason it wasn't working after that. And after scrolling through a bunch of pages of Amazon reviews for the motor, I found one person who had the same issue, and he had Arduino code listed that he uses a workaround. It basically involved setting the motor to every individual angle rather than just one angle and having it move. After that, the last thing was to connect the Nerf power to the relay, and that worked very easily, worked as planned. And here's a video of what we have so far. So the 2 stepper motors, they simulate the turning of the gun. Then the gun is activated and the servo moves to pull the trigger. We still need to mount the servo and the steppers, and we need to write code for the webcam actually being mounted on the gun and moving the motors corresponding to where the face is detected. But overall, we're in very good shape. Thanks for watching our progress report. I hope you enjoyed walking through our learning progress with us. Goodbye.